Hello, everybody. I guess by now you know who I am, but I still introduce myself. I'm Catherine Chauvel, President of the European Association of Geochemistry. Collaboration with other scientific societies is key to building a strong geochemistry community. Therefore, it is an honor to have several societies present their awards at the Goldschmidt conference. I first invite Jacinta Ensweiler from the International Association of Geoanalysts. Jacinta.
Thank you, Catherine. It's my pleasure to invite Jing Jiao Zhu to receive her certificate. And our next awardee is Ming Yang. Please come here. Thank you so much.
Thank you, Jacinta. I now invite Fen Zhengteng from the Shen Susan Foundation. Oh, here you are.
The Shen Susan Award is designed to recognize exceptional geochemists under 40 years of age who work in mainland China, Hong Kong, Taiwan, and Macau. This year's Shen Susan Award goes to Professor Yuan Li for his experimental work on the nitrogen and the carbon geochemistry in the deep earth. Yuan, come here.
Thanks, Van Deng. Finally, I invite François Chabot from the International Association for Geochemistry. François?
Thank you very much. I'm very delighted to be able to present several of the awards from this year and the past 2 years by the International Association of Geochemistry. The first is the Vernadsky Medal, which recognized colleagues for their distinguished record of scientific accomplishment in geochemistry over the course of his or her career. It's a great pleasure and a great honor for me to present, on behalf of the International Association of Geochemistry, this award to Stu Brantley, Barnes Professor of Geoscience at Penn State University. The scientific achievements of Sue and her group in the field of geochemistry and surface science are very impressive and outstanding. They have led to a renewal of ideas in all fields related to our understanding of the complex processes that control the chemical composition of water and its interaction with rocks. These advances include the measurement and prediction of rates of natural processes, including chemical weathering with and without microorganisms, the measurement and modeling of how rock turns into soil, as well as the impact of hydraulic fracturing on water, of natural water chemistry. But this list could be much longer, and I will stop just now because we have not a lot of time. Last, but certainly not least, Sue was a truly leader in terms of the emergence and development of the critical zone concept, as well as being instrumental in the growth of the international community working on the critical zone. Sue has been a source of inspiration and a role model for numerous of her colleagues and students. Thanks a lot, Sue, for all your accomplishment, our achievement in science, and thank you also for your involvement in the International Association of Geochemistry. Congratulations for this medal. on behalf of myself, the association, and all of your colleagues. So now I will continue, and I am very pleased to present two other awards from the association. The first is the Harman Distinguished Service Award, which recognizes outstanding service by an IRGC member to the association and to the geochemical community. This year, I'm very pleased to present this award to Michael Kerstnen for all this dedication to the IGC journal, which is Applied Geochemistry, as executive editor for more 10 years. Michael is professor of geochemistry at the Johannes Gutenberg University in Mainz in Germany. He has renewed and revitalized applied geochemistry. Thanks to him, applied geochemistry has become today one of the leading journals in geochemistry. Thanks a lot, Michael, for all your work. I am pleased also to present the IGC Fellow, which is bestowed to scientists who have made significant contribution to the field of geochemistry. In 2020, it was awarded to Bernard Meyer, professor at the University of Calgary, for his work on the development of geochemical approaches to determine the sources, the transport, and the fate of nutrients and contaminants in surface and subsurface systems on the continents. Because of the COVID, of the pandemic, this award could not be presented to Bernard. I'm delighted on behalf of the International Association of Geochemistry to present it to him this year at the Goldschmidt conference in Lyon. Thanks a lot. Bernard. Thank you very much. And it's all is over.
Thank you. Okay, so now I'd like to invite Carmen Sanchez-Valle, who is the co-chair of this meeting, to introduce today's plenary speaker.
So good morning. It's my pleasure to introduce today's plenary speaker, Abdoulatif Abass Saley. Abdoulatif is a mining geology engineer and researcher at the Department of Geoscience, School of Mining, Industry and Geology in Niamey, Niger, specializing in mining waste and pollution. After receiving his engineering geology degree, Abdoulatif spent several years in the mining industry as an exploration geology, mostly dedicated to the prospection of gold and uranium resources, before embarking in a research and teaching at the University of Niamey. He's currently working on his PhD on mining, waste, and pollution in artisanal and small-scale mining environments. And his research involves multidisciplinary approaches combining remote sensing, geochemistry, mineralogy, geostatics, and artificial intelligence to track the distribution of heavy metals in natural environments as a result of anthropogenic activities. So without further delay, please join me to welcome Abdoulatif to the podium for his plenary lecture. Thank you.
Hello, everyone. It's a pleasure for me to be here today to discuss about artisanal gold mining on West Africa. My name is Abdoulatif. I am a geologist. Now I am a geologist teacher. I do a PhD program on mining and environmental sciences. And I'm here to share with you some knowledge about artisanal gold mining in West African country, in particular Sahelian countries. As soon as we mention the notion of natural resources, we automatically refer to African continent, which is the richest region in natural resources. Africa alone possesses more than 60 different types of minerals, such as, and it is a third world's resources. The continent contains 19% of platinum reserves, 18% of cobalt, 60% of 18% of coltan, 60% of cobalt, 70% of tantalum, 46% of diamond, 40% of world gold reserves, and 10% of oil. The gold has played a key role in the evolution of human society. It has been the barrier of multiple economic, political, environmental, and symbolic stakes. The West African continent, particularly the West African Craton, has a long history of gold since the Middle Age, when emperor and emperors became famous due to the large quantity of gold they possessed. Such is the case of the Empire of Ghana, the Empire of Mali, with his emperor named Mansa Musa, who is now considered as the richest man on the world. His fortune is evaluated as $400 billion. During his travel to Mecca for pilgrimage, he took with him 60,000 components, 12,000 slaves, and 100 camels, each carrying 150 kilos of pure gold. It's reported that when he arrived at Cairo, his gold flowed freely, that the local currency was devalued, and the country took 12 years to record this devaluation. The potential, the gold potential in West Africa. The West Africa is the first part, is the main part of Africa which contains the large quantity of gold resources. This gold resources is located on Precambrian formation, such as volcano-sedimentary rocks, which are metamorphosed in regional conditions. And the West Africa is the third world has the third world gold potentiality after Australia and Canada. In this part of Africa, we have many countries which exploit gold, and the major countries are Ghana and Mali. In Ghana, for example, in 2019, the gold production is 142 tons, and for Mali, 71 tons. After these two countries, we have another countries like Burkina Faso, Côte d'Ivoire, Guinea, Senegal, Mauritania, Niger, and another countries in which the gold is produced. Here we have a location of some main gold production area around the West African craton. All of this gold are located on the major shear zones. After the industrial gold production, we have artisanal gold production, which is developed in the West African countries, in particular the Sahel region. The Sahel region concerns the country like Mauritania, Niger, Mali, Chad, Sudan, and Burkina Faso, Côte d'Ivoire. In these countries, people, some agricultures with the agricultures are converted to gold miners to reserve their daily needs. In these countries, like in Niger, we have more than 450,000 persons who works on artisanal gold mining, and more than 2 million persons depend on this activity. Or this person, we have sometimes some traders which works on sites, on mining sites, and other activity associated with the gold exploitation, artisanal gold exploitation. Or this activity has a high mobility on the area. When a new gold rush is announced, people automatically leave the site and go to the new site to try to get some gold resources. In Niger, the artisanal gold mining started in 1983, 1984, with a severe drought, which is caused in all the Sahel region. And the activity started in the western part of Niger called Liptako, in the site named Koma Bangou. Now we have 4 main zones of artisanal gold exploitation in Niger: the Liptako with Precambrian rocks. We have the soft Maradi in sedimentary rocks in alluvium. We have the Damagram Monio in Precambrian rocks. We have the mountain of Aïr in the northern part, and the Aïr-Djado zone. Actually, the production of gold in Niger is increased with the high discovery of new mineralization area. In this table, we have some value of artisanal gold production. For example, in 2021, the artisanal gold production is 44 tons. This artisanal and small-scale mining covers individual artisanal mining and semi-mechanized mining and mining of slag and heap and tiling from mine and quarries. Now the sector is governed by an ordinance made in 2006. In Niger, we have more than 200 artisanal gold mining sites. And the extractive sector in Niger included the artisanal and industrial mining, account for 43% of the total export and represent 10% of the GDP. This artisanal mining is making on many ways. Sometimes people extract ore by shift. Sometimes they use metal detector and they exploit gold on alluvium. For example, we have some pictures in the southern part of Maradi in which people extract gold on alluvium. This is the case of Niger. In other countries like Côte d'Ivoire, people use the dredging system in the rivers. Sometimes they do some small open pits. They use the gallery, or they exploit gold on lateritic. Before installing a new site, people go to the first stage, which is the prospecting. In this case, they use sometimes the scraping soil on laterite. They use some metal detector to search some pepites. And sometimes they search gold on the trench digged by mining company which was on the area. After they discover, they began to dig wells and to extract ore. For the sinking, they used traditional tools to sink. And when the well is deep, they use a ventilation system for people who works on the pits. After, they take the ore and put on bags, and they go to the center of crushing. In this center, they use traditional tools. Sometimes they use mills to crush the ore. Here we have some example of crushing, manual crushing, and manual shaving of the ore.
Nous sommes ici sur le site d'orpaillage de Dikondi, à quelques encablures de la ville de Gaoua. C'est la capitale de la région du sud-ouest et chef-lieu de la province du Poni, devenu un site à ciel ouvert, tant l'orpaillage a pignon sur rue. Ils sont plus d'une centaine de personnes chaque jour à creuser, concasser et laver pour trouver de l'or dans une certaine vie communautaire, explique Yaya Traoré, alias Koroba, orpailleur.
L'or a fait beaucoup de choses. Beaucoup, ils ont gagné, ils ont payé des voitures même, des motos. Moi-même, seulement j'ai payé des motos. Je suis en train de construire même. Ici, si on trouve que quelqu'un qui est malade, on fait réunion. Chacun n'a qu'à donner contribution. On va prendre la personne là, aller à l'hôpital soigner. Quand on va concasser comme ça, aller à la machine, écraser, venez laver. On met au mot et puis on mélange. Ça devient comme banco. Tu finis maintenant et c'est là-bas, tu mets mercure et tu frottes pour que le mercure là s'attrape. L'or là. Mais sans mercure, l'or là, ça ne peut pas sortir.
Here we are in one of artisanal gold mining sites in Burkina Faso, in the region of Gawa. He explained that many people, gold makes fortune for many people makes fortune on gold. Some once pays cars, motorbikes. He pays many motorbikes, and now he is building his house from the gold revenue. And he said that after crushing the ore, they use mercury and detergent to wash gold and to take the fine gold grain. This is how he said in this. So here we have, after crushing, the ore was washed by traditional tools like slush with water. Here we have some examples of traditional slush in Niger. Donc, after they take the puppets, they use mercury to amalgam the gold concentration with mercury, and they burn the amalgam with blowtorch to evaporate the mercury and recover the gold. After, the waste resulting from gravimetric washing was used and processed with another tools called Chinese mill. Now, in West Africa, people introduce another new tools for the amalgamation, which called the Chinese mills. And the ore was blown with mercury and crowned. After they took the solution and extract gold from the mercury. This process is very, very harmful for environment. After the waste resulting from gravimetric process was introduced in chemical treatment center. In this center, they use a solution of cyanide and water, and this solution, after 1 day, the gold solution was recovered in tubes, in some tubes, with zinc plate. Donc, this zinc plate cemented the gold and they take the plate to extract the gold from this zinc plate with nitric and sulfuric acid. You have two equations for this process. The first is the reaction of gold on cyanide solution. The second is the reduction of gold by zinc plates. After this zinc plate was the zinc plate, they use sulfuric and nitric acid to dissolve the zinc plate, and they recover the gold concentration by burying the solution with zinc, with nitric and sulfuric acid. And the last, after burying, we have only the gold concentration on the system.
Sur ces sites, afin d'accroître leur productivité, les orpailleurs utilisent de façon anarchique des produits chimiques tels que le cyanure ou le mercure pour l'extraction.
Le sable.
Cette utilisation abusive des produits chimiques dans plusieurs secteurs d'activité contribue à la dégradation rapide des sols.
Here is the process of the cyanidation. Donc, he explained that people use some chemicals like mercury and cyanide to extract gold. And this process is very harmful for the environment. This is what he explained on this video. After the gold is recovered, they use a traditional method to make ingot on the sites. Here, for making the gold ingot, they use only coal and salt. The gold is they put gold in a bowl, and they put salt in this gold, and they put it on the fire. After sometimes they take the liquid, and they use traditional meal to make ingots. This artisanal gold exploitation is very harmful and has many impacts on environment, like land degradation, during the extraction, they extract rocks, and this pile of rocks, which cannot contain ore, form many heaps on the environment, and sometimes these rocks contain some minerals like sulfur, which can be oxidated and generated sometimes mining drainage acid. Here we have some case in Niger which show the land degradation. Sometimes when they discover a new area, automatically they lift the sites, and we have sometimes some sites which are abandoned with any protection. We have heaps, we have well, and sometimes animals come here, and sometimes they fall down on wells. Sometimes when they dig, sometimes they intercept the groundwater, and in this condition, they do a drainage of this groundwater. But in many areas, the exploitation zones are in Precambrian rocks, like volcanosedimentary and granitoids, which can contain fractured groundwater. And when they do this drainage of this groundwater, sometimes people use this water for their domestic uses. And sometimes this water contains some pollutants. For the crushing and the grading, we have the smoke generated by the mills and the engine oil. Sometimes during the crushing, we have the dust which is generated. And when they use manual crushing and grading, it makes the losing of soils and the formation of small holes at the crushing and grading seats. During the process, the tiling come from process is abandoned on the sites. Sometimes the process generated when they use a lot of acid, it's generated the acidification of soils and waters. Here in picture B, when we take the pH of this water, the pH is 2. It's a very acidic water. And this water can sometimes be infiltrated on soil. Sometimes we have the spillage of chemical on the sites. Here we have in D the plate of zinc. And the area which they use to process is an unprotected area. You have no protection on the areas. We have some economic impacts, like trading, which is very developed in the area. We have some social and health risks. Here we have some dermatosis. We have a corpse of goat, which is drinking the cyanide water. Sometimes they use cyanide without protection. And here we have a camp for gold miners in the desert, in the Aïr-Djado area. Here we have our study area, which is Koma Bangou, which is located in the department of Terra. Koma Bangou, when during the prospection, they estimated the metal tonnage of 21.3 tons of gold, but it is in 1992. In this time, the gold price is very low. At the site, the ore is considered as the condition is not. They cannot be extracted at this condition, and after the government make the site an artisanal gold mining site. The site is located on the volcano-sedimentary rocks of Diaguru Darbani. Then we try to map the waste come from this extraction, the map from extraction area and cyanidation area by using Landsat imagery, a time series imagery. We apply different method of process of treatment, like minimum noise fraction, band ratios, principal component analysis, to take the best method which can discriminate the extraction waste and treatment waste. And after we do a time series, after we take the best method, we do a time series on Landsat imagery. Here we have 4 cases in 1988 to 201, 210, and 2020. Here we have the result of the extraction, cyanidation, and extraction area. Here is the result of the waste expansion with gold prices. And see, we see the evolution from 1984 to 2020. After we try to evaluate the pollution on this site. Before evaluation of the pollution, we calculate a geochemical baseline for the area, and after we calculate an enrichment factor, and we try to identify the source of heavy metals. The data we use are the PXRF data, which are calibrated with ICP-MS data. In this case, we use 4 elements: arsenic, copper, lead, and zinc. For the geochemical baseline, we use the cumulative frequency distribution method to identify the anthropic and natural concentration of this element. Here we have the result for arsenic, copper, lead, and zinc. So we calculated the enrichment factor, and we map this factor on the area. We have here the enrichment factor for arsenic, and here we see that the high concentration of arsenic are located on cyanidation area. It's the same case for the copper, for which the high concentration are located on the cyanidation area. Against for the lead, and against for the zinc. After, we try to identify the source of heavy metal by using multivariate analysis, like principal component analysis. In this case, we have 3 source of element. We use night element. After making PCA, we have three sources. The first source is associated with cyanidation waste, which is anthropogenic source. In this case, we have zinc, sulfur, copper, and mercury. The second is associated to the ore system. In the area, the mineralization system is associated to arsenic and lead. And the third group is the lithology group. In this copper, we have iron, vanadium, titanium, and chromium. This is the result of the principal component analysis. In the first and for the first component, we have mercury, sulfur, zinc, and copper, which are associated with acidification waste. And for the second, we have arsenic and lead, which are associated with cyanidation waste, and in some cases, cyanidation area soil, because the cyanidation area soil were contaminated by the cyanidation waste. Here we have the plot of the PC1 and PC3. For the PC3, we have iron, titanium, vanadium, and chromium, which are associated with gold panning area soil and the cyanidation area soil. Donc, this is a lithological signature. After, we make a sample hierarchical clustering, and we see that we have in a lower distance, we have anthropogenic groups with sulfur, zinc, copper, and mercury. We have the ore system with arsenic and lead, and lithology system with iron, vanadium, chromium, and titanium. But when we take a high distance, we have two groups, The first groups will be with sulfur, zinc, copper, mercury, arsenic, and lead, and second group for the lithology. In conclusion, we say that the artisanal mining, the artisanal gold mining is a fast-growing activity in West Africa. It contributes to the socio-economic development of the area. It is a fast-changing and revolutionary activity by the new technology. Today, with the imported technology, gold miners arrive to recover a lot quantity of gold. It causes environmental impacts like land degradation, soil and water degradation, and pollution, acid mining, drainage, and social impact like degradation of morals, various diseases, and we observe the deschooling and child labor. We conclude to say that remote sensing is an ideal tool to map and monitoring the evolution of artisanal gold mining sites and the waste generated over time. After, the geochemistry tools, the PXRF, is a reliable tool for the rapid acquisition of low-cost chemical data for the assessment of metal pollution in mining sites, as well as for determining the source of heavy metals. So this is the end of my presentation. My English is not very good. I'm Francophone. Thank you very much.
Thank you very much, Abdoulatif, for the very interesting talk. There is two announcements before starting with the questions. The people who sign for meeting the speaker afterwards, please reassemble around the stage after the questions. And the other announcement is that if you have questions, you should use the microphones that are located on the sides of the amphitheater. So, is there any question for the speaker?
Hello, thank you. That was very interesting. I was wondering if you could maybe say more if there's connections between the medieval exploitation of gold in the region and sort of this modern artisanal gold. Is there some sort of lineage there, or is it a purely modern phenomena, or how are the two related, both either socially or methodologically?
There is a relationship between medieval method and new methods. In all gold mining sites in West Africa, they continue to use medieval methods like vining, like using like digging. Okay, this is the old method, but now with the evolution, they use new methods with machines and other tools. In the same site, you can see some people works with old methods, and another people works with new methods. And when the people get money, they go to buy tools, and the old methods are for people who have not money to buy new tools for exploitation.
Okay. Thank you for your very interesting talk. You mentioned that there are many human people involved in that. They are poor, they have disease. Are you working with human science colleagues to study the impact on the humanity, on the population working there?
Yeah, we work together with social sciences and health sciences. But it's very difficult in this condition with insecurity in the area. It's not possible to go together. Sometimes you want if a team wants to go on field, it's impossible for all team members to go on field because we have high insecurity in the area. Sometimes the geologist can do all the works. You do environmental science, mineralization, social sciences. Sometimes we took comment ça s'appelle les enquêtes là? We took survey papers with social and health sciences persons, and we do the question on the field for them.
Alors, I really enjoyed your talk. I think it's very important that the people living in Europe or in the States have a little bit of an idea of how things are extracted and when they use the metal afterwards. It's really, really useful. I have a question about you mentioned at the beginning there is some industrial sites with big companies. And so you had two types of extraction. There is the industrial extraction and the artisanal extraction. Right. And you gave the number of people who can live out of the artisanal gold extraction, which was close to 3 million. What is the proportion of African people who get a job and survive on the industrial branch? Is it comparable, smaller? No? I mean, what is the impact, the difference?
In the gold artisanal mining, the estimation of people who depend on this activity is around 6% in the West African region. 6% depend on this activity. But people who do the activity is less than 6%. Because in a site, we have many associated activities which can do by another peoples and which can contribute to the socio-economic development of individuals, families, and all the countries. Yeah.
Yes, please, go ahead. Hello.
I have a question. Your presentation was wonderful because it's very important for the health and the people. Okay. But I have a chemical question. Okay. Do you know if the cyanide is complex or is free? Because it's completely different effect in the wastes. The cyanide when it's free or when it's complexes. Do you have an idea? Do you have data?
Well, at first time, the cyanide is free. But after the solution, it's complex.
It's complex.
Yeah.
With iron.
It's complex, sometimes with iron. In the West, the form of the cyanide is the complex form.
Okay, thank you. Because it's less toxic. A little less toxic.
Okay.
Thanks.
Yeah. But in the area in which we work, it is a desertic area. We have there is no water. We have the cyanide is degraded on the environment in a few times. It's very hot, no humidity, and the condition is that the cyanide is degraded on few times in the West. Yeah.
Thank you. Thank you for your excellent talk. I wondered if Niger has ratified the Minamata Convention on Mercury.
Okay.
So that's first question. And then the second question is there any, from what you understand, are the miners formalized in any way? I know that formalization is discussed as a means of controlling the child labor and some of the chemicals used and some of the chemical exposure? Thank you.
Yes, the Niger is a member of the Memomotor Convention for Mercury. And in Niger, the government is in the process of the artisanal gold mining formality. Now we have many associations and many non-government organizations and other research centers which work with gold miners, because now the gold miners form their own association to exploit for exploitation. And then we have many sensibilization on the site, how to use chemical, how to protect environment, how to dig, how to secure their installation, their pits or gallery, and to avoid the child labor, and to protect the site. But the country is the phase of the formality of all this artisanal. In the past, the government having according an intention to these activities. But when they install a center for making lingo, the government, with the high production of gold in the country, now the Ministry of Mine, Ministry of Economy and Security, donc, now these three ministries works and with gold miners, and the formality processes is engaged in the country. But the activity is very governed by law, but the formalization is not operating yet. It's not yet operating. Yeah.
Is there any question? Please.
You talked about how difficult it is to work like a multidisciplinary team to go to sites. That makes me want to ask this question, that's how do we ensure that the data we get, like for instance, I was at House Geochem yesterday, and I noticed that much of data we have in Africa is much from South Africa and probably East Africa, no much data from West Africa. And part of the problem identified is the reliability of data we can give. So if there are problems to visit this site to do ground truthing, how do we guarantee that, okay, I mean, how do we share our data with international community to, that will be verifiable? And I want to give a very serious problem that is occurring now in Nigeria. It's nearly impossible to visit these sites because the potential gold mining sites are just places where bandits that are maybe using that as their business. So it's nearly impossible for scientists to get there. And I wonder if such scenario also happens in Niger. And then if this is the case, how do we ensure that the data we get are reliable to give to the international community? Thank you.
I think that the case of Nigeria and Niger is not we don't have the same case. In Niger, for example, all sites where we have banditism or terrorism or another insecurity problems, the government take the, okay, donc the government close the site en fait. Okay, it is impossible for gold miners to go to this site to work. Now, all activities on gold mining, on artisanal gold mining, are located on the northern part of Niger. In the past, all activities are in the western part. But now, with the terrorism, with the insecurity, okay, donc all miners are moved to the northern part because this part is the most secure part in Niger. So people, researchers can go in this part to do their activity, no problem.
We just go with the last short question, and then we have a few questions on the chat also that we should address. Thank you.
Thank you very much for your talk. I was wondering, do you know what happened to the gold after? Like, where is it sold? And how is it entering the market? Where is it going?
The market is the freely market, okay? Gold miners, they sell their production. Sometimes, in many situations, we have we have one people who can pre-finance the activities. Okay, now sometimes we have 10 people, they form a group to exploit, they come to see a rich man, okay, donc he gives them money and food, tools for works. After the production, they sell this production to him, okay, donc sometimes people sell their production freely on the market, okay, but in the major case, the production of gold in West Africa, the major production go to Dubai. Go to Dubai, sometimes in Swiss. A few quantity go to Swiss, but the large quantity go to Dubai. Okay, all gold traders in Niger go to Dubai with their gold quantities. Okay, but to be a gold trader, you can take a authorization from the mining ministry. Okay, but we have some small traders in the site which can buy and to gold producer, and they sell their gold to the big traders. But the market is an open market. Yeah.
So I will pose the questions now from the chat, from the people who is online. So one of the questions is, how did they manage gold artisanal mining during COVID period?
In Niger, during COVID period, COVID is not considered in Niger as a disease, if you want. I will be clear with you. So in many sites, people work COVID. Sometimes people say that it's for people who travel. Okay, we have some, but in some sites, the activities were being impacted by COVID, because the accessibility to some market. Sometimes with COVID, the travel is not guaranteed. Sometimes the product cannot be entered on the site at time because there is no camion or other. Sometimes borders were closed. It's impossible for cars or for big cars or small cars to enter with products. So it affects the production in this condition. But with a gold miner, for them, COVID is a simple disease like rheum.
Like a cold, basically.
Like a cold, yeah. Please.
Okay, so let's ask another question from the chat. Are data from other gold-producing countries in Central Africa that is also considered in your presentation, in comparison to Niger? Ça compare les productions artisanales de gold dans d'autres pays de l'Europe, de l'Afrique par rapport au Niger.
We don't have a comparison value for other part of Africa, but the large gold quantity is produced in West Africa. We don't have data, many data for central or other part of the continent, but we know that they produce gold on Central Africa, on Cameroon, and on other countries, but less than West African countries. Now, in Burkina Faso, in Niger, for example, we have a large gold production by artisanal mining. In Niger, for example, we have a small industrial mine, but its production is very, very less than the gold product by the gold miners. The West African gold production in artisanal condition, I think that it's very biggest done for another part of Africa.
And just the last question, that is also from the chat. The question is mining along the shear zones, or they only take aquiferous quartz samples?
Aquifers?
Yep.
Along the shear zone.
Yep. If you are just, si vous utilisez simplement les productions des shear zones ou simplement les quartz, aquifères de quartz?
Well, we have many types of, I show it that we have many types of production. In some condition, we have the large quantity. The large quantity of gold is produced in shear zone condition, in shear zone area. But we have some area in which gold is produced on alluvium. We have, for example, in Niger, all the gold produced in the area of Maradi is only on sand, alluvium. Okay.
Yeah. So if there is no any more questions, let's thank Abdoulatif Saley again for his very nice presentation. Thank you.
On n'a jamais eu autant de questions.
Je pense que c'était... Oui, en fait, il demandait pour des... J'arrivais pas à lire la question. C'était sur aquifère, aurifère. C'est des quartz qui sont de l'or.
Oui, dans les systèmes de shear zone, en fait, c'est le quartz qu'ils prennent.
Oui, voilà.
C'est juste le quartz aurifère.
Voilà.